Hello, my name is Michael Blandino, and for my AP research project, I studied the correlations between cadence patterns in songs and the functions of music preference. Across the globe, music serves as an important hobby, pastime, and cultural phenomenon. Today, thanks to online media such as Spotify, Apple Music, or SoundCloud, there seems to be endless music to listen to. Music recommendation systems, or MRS, have been adopted by music media companies in order to help cater to the listener's specific tastes in music. According to Bauer and Shuttle, the ideal MRS would suggest the right music to the right user at the right time. However, Bauer and Shuttle argue that current MRS do not adequately meet this need. Recommendation systems, it is suggested, need to more effectively account for the listener's taste in music preference. Music preference can be interpreted in many ways, but its simplest definition is whether or not a listener likes a song. Schaefer adds that music preference involves how listeners feel, perceive, think, and behave in response to music. For the purpose of the study, music preference is understood to mean how listeners think and behave in response to music, described by whether or not a listener likes a particular piece of music. Every person has a unique sense of music preference, determined by a multitude of factors. LeBlanc, in his proposed model of the determinants of music preference, suggests factors such as musical training and personality. These music external factors are unrelated to the piece of music in question, and instead describe the listener or the surrounding environment. More recent research has considered concrete relationships between music external factors and preference for specific types of music. For example, Dobrota and Riek found that participants with personality traits such as optimism and agreeableness prefer happy-sounding music, with faster tempos and major keys. In addition to being affected by the listener's specific traits, music preference is affected by the kind of music that is being listened to. In LeBlanc's model, this is suggested by variables such as complexity and physical properties of the music. LeBlanc mentions musically oriented properties such as harmony and rhythm, but notes that his model does not take a position on such music theory characteristics. LeBlanc's work has highly influenced the direction of music preference research in recent decades, so little has been discovered about music preference in relation to music-specific qualities. One problem that has arisen in terms of describing music preference is how to describe exactly what a listener prefers. Colloquially, music is grouped into genres, such as rock or pop. However, Renfrow, Goldberg, and Levitin observe that genres are limited in describing music preference because they are broad and generally poorly defined. Renfrow et al. Performed a factor analysis, which yielded 5 distinct and well-defined factors that can be used to describe types of music for which one might have a preference. These factors are named mellow, urban, sophisticated, intense, and campestral, and form the acronym music, and are shown to be a result of preference for both genres as well as preference for specific musical attributes. However, some of the music-specific attributes used in the factor analysis, such as electric, instrumental, and dense, are generic and hard to quantify. Renfrow et al. Suggest that their music model could be improved by the inclusion of such attributes as harmony. Bauer and Shuttle assert that in order to suggest the proper music to a listener, music recommendation systems should become more context-aware. One way in which this could be accomplished is through the use of functions of music preference. Here, a function can be understood as a way in which people use music to serve their particular needs. For example, one might listen to a particular song in order to relax or to improve their mood. Schaefer and Settlemyer conducted a study in which they asked participants the extent to which they agreed with statements regarding different types of music. Analysis of the results yielded 7 statements which Schaefer and Settlemyer deemed the most important music preference functions. It is shown that the expression of these functions can be a strong indicator of music preference. In other words, if one reports a high degree of a function being served by a particular song, it would be reasonable to conclude that the listener has a preference for that song. It should be noted, however, that not every function needs to be expressed in order for one to have a particular preference. My research goal was to discover if there are any worthwhile relationships between music theory characteristics and music preference. Having found that there is a lack of research regarding musical attributes such as specific harmony types, and knowing that functions of music preference can provide a means of determining whether one shows a preference for a song, I now ask the question, how do the types of cadences in high school students' favorite pieces of music relate to the most important functions of music preference, as defined by Schaefer and Settlemyer? The answer to this question would help to determine which types of songs, from a music theory perspective, could serve particular needs to listeners at a given time, meeting Bauer and Schettle's description of the ideal context-aware MRS. In addition, if noteworthy correlations are found, the direction of music preference research could be shifted more towards music theory characteristics. Finally, as described by Dobrota and Riak-Ezergovac, any improvement in the understanding of music preference would aid music teachers in selecting music to teach to their students. Cadence refers to the last two chords of the musical phrase, where a phrase can be thought of as a single musical sentence. Because they involve the movement of chords, cadences are important harmonic structures. Songs are typically composed of a combination of 7 chords built from a scale, with each chord being given a Roman numeral to indicate the note of the song's main scale, which the chord starts on. For example, a chord starting on the scale's first note, and also including the scale's third and fifth notes, would be named the 1 chord. The 4 chord, however, consists of the scale's 4th, 6th, and 8th note. In Chapter 8 of their textbook, The Practice of Harmony, Spencer and Bennett identify 4 types of cadences. The authentic cadence goes from a 5 chord to a 1 chord. The plagal cadence goes from 4 to 1. The half cadence goes from any chord to 5, and the deceptive cadence from 5 to any chord. While there are several other types of cadences, this research will only focus on these 4 patterns. To repeat my research question, I asked how cadence patterns of high school students' favorite pieces of music related to the most important functions of music preference served to listeners. I hypothesized that several strong correlations would emerge through my research, and that these correlations would be largely between authentic and half cadences and functions that relate to a positive emotional or psychological response to music, such as makes me feel ecstatic and puts me in a good mood. I believe that this would happen because authentic and half cadences tend to be the most common cadences, and I have noted observationally that high school students tend to have strong emotional or psychological connections to their music. In an attempt to prove my hypothesis, I performed a correlational analysis using quantitative data. I tested for 28 correlations, 1 for each combination of 4 cadence types and 7 music preference functions. This required me to gather data that could be grouped in terms of an independent variable and a dependent variable. My dependent variable was the strength of each music preference function. I sent a Google form to all the students at my high school and asked them to think of 3 of their favorite songs. For each song, they were shown 7 statements, 1 for each music preference function. Participants were asked to rate the extent to which they agreed with each statement on a scale of 0 to 6. The independent variable for this method was the presence of each cadence type. For each of the 3 songs entered by each participant, I performed a chord analysis using the chord sheets provided by ultimateguitar.com. For example, one song I analyzed was Perfect by Ed Sheeran. The song is in the key of A flat major, and in the phrase, "You look perfect tonight," the song moves from an E flat major chord to an A flat major chord. In Roman numeral notation, this is a movement from a 5 chord to a 1 chord, indicating an authentic cadence. I rated the frequency of each cadence type in each song on this 4-point scale, which ranged from the cadence not occurring at all to the cadence dominating throughout the song. Once I had gathered all of my data, for each cadence function combination, I had information on how each served a function to a listener and how often a cadence occurred in each song. Above is the scatter plot of the data for the authentic cadence matched with "makes me feel ecstatic" to help visualize the relationship. The presence of the authentic cadence is plotted on the x-axis, and the strength of the function is plotted on the y-axis. Each data point on the scatter plot can therefore represent one song. Using Microsoft Excel, I performed 2 two statistical operations. First, I calculated the Pearson's correlation coefficient, R, which describes how close the data points are to a line of best fit. R can have a value between 0 and 1, with a higher magnitude indicating a stronger correlation. It should be noted that the use of Pearson's R assumes that the correlation is mathematically linear. I also performed a t-test for each correlation to determine the statistical significance of each correlation. Consistent with the music preference literature, a correlation was understood to be significant only if the p-value returned was less than 0.05, with a p-value of less than 0.01 indicating a highly significant correlation. In total, I had 29 students respond to my Google form to provide data for this study. Participants were aged 14 to 18, with a mean age of 16.5 and a standard deviation of 1.2. Therefore, 87 songs were submitted for my analysis. However, due to a lack of availability of several songs on ultimateguitar.com, several songs were removed from consideration, leaving only 61 songs to be analyzed. Based on the t-tests that were performed using Microsoft Excel, only 5 cadence preference combinations return statistically significant correlations, as shown in this table. Furthermore, only one cadence preference combination, authentic and makes me feel ecstatic, had a highly significant correlation indicated by a p-value of less than 0.01. Obviously, my hypothesis was incorrect in that several strong correlations did not emerge. Further refuting my hypothesis is the fact that, while 2 out of 5 significant correlations involved the authentic cadence, there were no significant correlations involving the half cadence. This bar graph shows the average frequency of each cadence type. Interestingly, the 2 least frequently occurring cadences, authentic and deceptive, were the only cadences involved in statistically significant correlations. Plagal and half cadences, while occurring more frequently, were not involved in any significant correlations. Upon further inspection, I noticed that the lack of abundance of deceptive cadences certainly skewed the correlation analysis, accounting for the unexpected high rate of deceptive cadences having significant correlations to music preference functions. This scatter plot visualizes the significant correlation between the deceptive cadence and the function makes me feel ecstatic. The 2 rightmost data points on the plot each represent one song. However, there is a large cluster of overlapping data points above x equals 0, accounting for a total of 59 songs out of 61. The deceptive cadence is rare in comparison to the other cadence types, and it can be seen that songs made participants feel ecstatic both highly and not at all when the deceptive cadence was not present. The cluster of data points, however, put a strong weight on the correlation, a false positive of sorts. Therefore, due to a lack of information on songs that contain deceptive cadences, the significance of the 3 correlations involved in this cadence type is called into question. Taking this into account, it can be seen that only 2 correlations emerge for which there is a reasonable confidence in their significance. While the fact that both of these correlations involve authentic cadences does support part of my hypothesis, my overall hypothesis is not supported. Cadence patterns may not be an effective predictor of music preference. While the use of cadence patterns was not found to be an effective predictor of music preference, I discovered that my data could be used to support the use of music preference functions as a way of indicating music preference. For each preference function, I calculated the mean response on the 7-point scale in order to show, on average, how important each function was to my set of participants as a whole. This bar graph shows these average frequencies, so the relative importance of each function can be seen. Some of the most important functions were puts me in a good mood, helps me appreciate music as art, and makes me feel ecstatic. This chart is a comparison of the relative importance of the 7 functions in my study and the relative importance of the 7 functions in Schaefer and Settlemeyer's study in 2009. Highlighted rows show alignment between the 2 studies, so it can be seen that 5 functions held the same position in terms of relative importance. This similarity supports the use of functions of music preference as a tool to measure music preference. There are several improvements that could be made to the present method to strengthen subsequent research. First, my research was limited by a small number of participants, which in turn limited the number of data points that could be analyzed. Furthermore, I targeted students at a single high school, which allowed for potential bias in my participant population on a geographic basis. This could be fixed by advertising the initial survey online, with the aim of gathering participants from across the country, or perhaps even internationally. Additionally, the use of Likert type scales restricted the domain of values for the independent variable. Rather than using a scale to measure the presence of a cadence, future research could represent the frequency of certain cadence types or other music theory characteristics as a percentage of the total number of that kind of characteristic. Finally, my research suffered from a lack of available information on the chord structure of certain songs, particularly those in the rap and hip hop genres. To account for this limitation, musical experts could perhaps be recruited, as people with sufficient musical training could accurately analyze chord structures by ear, eliminating the need for an online resource. It was mentioned previously that research in the field of music preference has underlying goals, most notably the creation of better music recommendation systems. In their 2009 work, Schaefer and Settlemyer uncovered additional functions of music preference, such as enables me to reminisce and can help me chill and tune out. The functions used in this study were described as the 7 most important functions. The users of music recommendation systems will likely have diverse needs, and the field would benefit from these additional functions being considered as well. In addition, while this research only focused on high school students, users of music recommendation systems could undoubtedly be of virtually any age. Whether the effect that music theory characteristics have on music preference is varied based on age group is a question for future research. But it is important that this question be addressed in order to create music recommendation systems that work for all people. Finally, since it was shown by the present study that cadences are not an effective predictor of music preference, future research should focus more on other music internal parameters, such as rhythm or instrumentation. Much research remains before the ideal music recommendation system, as described by Bauer and Shettle, can be created. The study of how music theory characteristics affects music preference in the context of music preference functions has the potential to be a strong aspect of this research. Thank you for your interest in my AP research study. For a list of references that were used in this presentation and throughout my research, please see the following slides.